All right, here's a couple of free responses that are related to polar coordinates and polar areas. First, the 2005 problem here. We're given the graph, and you're typically going to be given the graph of the polar equation. They don't want you to have to go find that in your calculator. And r equals theta plus sine of 2 theta is your equation here. And then they also tell you the derivative there so that you don't even have to worry about doing that by hand, although you clearly could do that by hand. It's not a very difficult one, but that was helpful. Part A wants to find the area bounded by the curve and the x-axis. All right, we know to find areas, we integrate 1/2 r squared d theta. They did that here. They happen to pull out the 1/2 since that's a coefficient, doesn't matter. We need to find our bounds by ourselves in this problem. You can see in the curve, we start from the angle of 0 going all the way around to pi. So your bounds are 0 to pi. Remember that everything needs to be in terms of theta. R equals this thing. So you're just going to substitute that directly in there. Let the calculator do the integration for you. Again, you don't have to do it in terms of theta. You can just leave it as x's in your calculator. You don't have to get into polar mode or anything like that to get that value out of 4.382 for your answer in part A. Then part B wants to find an angle theta that corresponds to the point on the curve with an x-coordinate of -2. Well, to find an x-coordinate, remember we do r times cosine theta. Going back to the basics of kind of the unit circle idea where x is cosine. So r times cosine of theta, substitute in for r there. Here's r times cosine of theta. We want to know where this expression would equal -2. Make the calculator do that for you. Graph this, again, just graph it as an x, and then graph y equals -2. Find the intersection. 2.786 is the number that comes out of your calculator. The key there is knowing r times cosine of theta gives you your x coordinate. Then in C and D, they turn this into more of a, just kind of a different type of problem. It doesn't matter too much that we're dealing with polar. It more turns into what derivatives tell you about curves and a max problem at the end. So part C says, okay, dr d theta is negative on that interval they've told you about. And I want to say, well, what does that tell you about r? Well, if dr d theta, which is the change in r with respect to theta, is negative, you've got a negative rate of change, that tells you that r must be decreasing. And since r represents the radius or the distance from the pole out to the curve, that tells you that the curve is getting closer to, they say to the origin, I would have said to the pole, but they clearly don't care either way there. But basically the points on the curve are not as far away from the pole as they were initially. And that's because r is decreasing, and r is decreasing because the derivative of r with respect to theta is negative. And then part D says, where in the first quadrant, at what value of theta, would you be the farthest from the origin on this curve? So we're looking for basically a max, and we know the max is going to happen either at an endpoint or maybe at any sort of critical points. Critical points happen where your derivative is 0 or where your derivative is undefined. We have the derivative, dr d theta, was actually given to us in the problem. We want to find critical points, so we set that derivative equal to 0. Again, make the calculator solve that for you. Pi over 3, but 1.047 is what the calculator is going to give you there. If you graphed 1 plus 2 cosine 2x equals 0. So 1.047 is going to be your critical value. And then you want to find the distances from the origin at not only that point at pi over 3, but also at the endpoints. So you're just going to sub those into r. R equals theta plus sine 2 theta. Substitute those values in. The r happens to be the greatest when theta equals pi over 3. So it is actually at the critical point and not at the endpoints. So having that pi over 3, or that 1.047, that's just where your critical point is. That's where that first point comes from. Second point, your justification needs to involve you checking the endpoints as well and finding the largest value. So that's the 2005 problem. So the average on that one was 3.5, so a little bit lower. quite a bit lower actually than the parametric ones that we saw before. All right, let's talk 2014. Two different curves in this one. We have r equals 3, which is just a regular old circle, and then r equals 3 minus 2 sine theta. We want to find the area of this shaded region, R. It said it's inside r equals 3. It's inside that other graph as well. And we want to find the area of that. The quickest way to find that area is to think of it as two separate pieces. First, just think about that piece that's in the first quadrant. That part's under the other, the 3 minus 2 sine 2 theta curve. So we can find that area by going from 0 to pi over 2 under that curve. So 1/2 r squared d theta, your bounds are 0 to pi over 2. This portion here tells you this shaded region here, this area that's in the first quadrant. The rest of that region is simply 1/4 of a circle with a radius of 3. So the whole circle area would be 9 pi, and then just 1/4 of that is where that 9 pi over 4 comes from, which they end up giving you a decimal answer at the end of 9.708 where you combine those two things. So quickest way to do that is just think of that as two separate regions and find each area there. Part B wants the value of dx d theta when theta equals pi over 6. So we need to get x, and we know that x is r times cosine of theta. And if you have that written there, there's that first point expression for x. R times cosine of theta. The derivative of that at pi over 6, make the calculator do that. You don't even have to do the product rule, the chain rule, or anything else. Throw that in Math 8. Again, don't even have to worry about changing this to polar. Just throw this expression in Math 8 when your variable equals pi over 6. Should spit out negative 2.366 is your answer there. Then part C, the distance between the two curves changes from 0 to pi over 2. Clearly, you can see that happening in the, sometimes these are closer together, sometimes they're farther away. Find the rate at which that distance is changing when theta equals pi over 3. Well, so first we need an expression for the distance between the two curves. That's a top minus bottom thing. Just like we've used when we've done like area between two curves in the past, just with regular coordinates. So the distance between the curves is just the top minus the bottom distance anywhere along the way. So 3 minus this expression for r, which simplifies out to just 2 sine 2 theta. And then we want the change in that distance when theta is pi over 3. So again, let Math 8 do that for you. Yes, you could take the derivative of this by hand. It'd be 4 cosine 2 theta, and you could evaluate that at pi over 3. But no reason to do that. Just do Math 8 again. Plug in pi over 3 as your x value and get a change of negative 2. And then finally, part D really goes kind of, this is a weird kind of question here. They say, all right, well, now the particle's moving along that curve, and d theta dt equals 3 for all values of t. Find the value of dr dt when theta equals pi over 6. So you kind of have to do some algebra manipulating here. That to find dr dt, you can think of it as dr d theta times d theta dt. And algebraically, those d thetas would kind of cancel out. So you can find dr d theta without too much trouble here because everything's already in terms of r and theta. And then they tell you d theta dt is always 3. So you evaluate dr d theta at pi over 6, you get negative 2. Again, just let Math 8 do that, and then you just multiply that by 3 and get an answer of negative 6. So I'd say part D is a pretty strange thing to ask, but if you can figure out that expression there, it's sort of like when you do, if you're trying to get dy dx, you do dy d theta over dx d theta, because the d thetas kind of cancel out there. Same thing happens in this case. You kind of think of it as dr d theta over times d theta dt. So there's a couple of AP free responses. We'll talk next time we're together if you've got anything else you want me to discuss about these.